Hey guys, what's up? Welcome back to my YouTube channel. In this video, I'll be teaching you guys all about factoring and the 4 ways that we do it in Algebra 2. So first up, we gotta start with the basics. What is factoring? Factoring is the process of splitting or dividing an expression into terms that are able to multiply together to get that expression. So for example, 3 times 5 is 15. So 3 and 5 are both factors of 15. Now we're going to talk about GCF, or greatest common factor, which is the biggest factor that you can split from an expression. For example, 3x plus 15. You can take one out of both of these things, but is that your biggest common factor? No, your biggest common factor is 3. So 3x divided by 3 is x, and 15 divided by 3 is 5. So your factors are 3 times x plus 5. If you distribute the 3, you get the same thing as the example, which is 3x plus 15. So that's how you know that they're factors. Greatest common binomial. So a binomial is a two-term polynomial. Remember that polynomials are sums and differences, and a binomial usually consists of a variable and a constant. Now let's look at this expression. In order to solve this, you would need two numbers that multiply up to 15 but add up to 8, and those numbers happen to be 5 and 3. So your factors would be x plus 5 times x plus 3, and the larger one is x plus 5, so that is our greatest common binomial. Now let's talk about simplifying the greatest common binomial. In this example, we started off with an expression and we ended up with two terms. But wait, one of them is a difference of two squares, which is x squared minus 1. And according to the rule of difference of two squares, this can keep being factored, and it would be x minus 1 times x plus 1. Now let's talk about binomials. So first, we're doing square of binomials. In math, you can use shortcuts called formulas to deduce your answers more efficiently. So the difference of two squares has this formula that you can follow. So in our example, 9x squared minus 25, 9x, the square root of that is 3x, which will be our a, and the square root of 25 is 5, which will be our b. And then we just plug that into the formula, and you get 3x minus 5 times 3x plus 5 equals that expression. In the bottom, you can see that I checked it, and since the b value cancels out, you get 9x squared minus 25. However, sum of two squares can never factor. They're prime, which means they're in their reduced form. Cube of binomials. Sum of two cubes has a formula, so let's look at our expression. 8x cubed plus 27. We need to cube root both sides to find our a and b values, which are 2x and 3. Now you just plug that into the formula and you get these binomial and a trinomial, and the resulting trinomial does not factor. Same with difference of two cubes, it's the same concept. You cube both things to get your a and b value, and then you plug it into the formula, and the trinomial for that does not factor either. So I had to put my phone on light mode so y'all could see these stupid PNGs, but this is the binomial theorem. She looks scary at first, but basically it's whenever you want to put a binomial into a really high power, like 4 or above, and you don't want to FOIL it or box it over and over again. You plug your binomial into this formula as n and k, you simplify it, and that is how you find your new polynomial. Factoring trinomials. So first we're going to go over square of a binomial. This is the formula for it. In the example, we have x squared plus 6x plus 9. Now we need to square root this part and this part to get our a and b values, and we plug that into the formula, and you get x plus 3 times x plus 3, which is also known as x plus 3 squared. Xbox method. So for this, we're going to go back to an example that we used earlier. So first you want to set up this grid, and on top you want to have your a and c values multiplied, and then on the bottom you want to have your b value. Now we have to find two numbers that multiply up to 15 but add up to 8. Those numbers happen to be 3 and 5. Since the coefficient of the expression is 1, you can just set that up as x plus 3 times x plus 5, and those are your binomial factors. Finally, you can factor using the quadratic formula. I plugged this example into the quadratic formula and I got two solutions, x equals 4 and x equals negative 3 over 2. But that's in zero form. In the bottom, you can see that I made it into factored form, so the factored form is x minus 4 and x plus 3 over 2. I did that by having it set to 0 and reversing that. Finally, we're factoring by grouping. The first way to do this is by grouping first and last terms. So in this expression, I split it up into two parts, so that would be these parts. And the GCF for this first binomial is 3x, and the GCF for the second binomial is 4. So you divide those out and you get 3x times x plus 2 plus 4 times x plus 2. And then you just separate those, and the factors are 3x plus 4 times x plus 2. Now onto the spicy part, special cases. So in this polynomial, we can see that the first part is the square of a binomial. And we learned earlier that we could split it into a plus b times a plus b, because remember this is a squared plus 2ab plus b squared. So a plus b times a plus b would be x plus 3 times x plus 3, and that equals x plus 3 squared. Now we're going to split up the y into a y here and a y there, and add it all together, and you get x plus 3 plus y and x plus 3 minus y. Remember, when you multiply a positive y and a negative y, you get negative y squared, which matches our original expression. Finally, we have our last expression. So you can see instead of the square of a binomial being at the front, it's at the back, and the y squared is in the front. Now, because there's a negative here, you have to change all of the signs when you put it into the parentheses. So that's what we did. And because the first term is a square and the last term is a square, you can get x minus 3 squared out of it. Notice, because this term has a negative, this has to be a negative also. And so now we're going to split the x minus 3 up into two parts here, and then the y squared up. Notice how they're both positive because the y squared is positive. So finally, you get y plus x minus 3 and y minus x plus 3. Thank you for watching my video.
And with that, I just have two more words to say. Obama out.